Okay, we've started recording. Welcome to SIG Windows, everyone. Today is June 29th. Hope everyone's staying cool out there. This is a CNCF meeting, so we follow the CNCF guidelines and code of conduct. If anyone has any questions, you can reach out to myself or any of the Kubernetes leads. And yeah, let's go ahead and get started for today's meeting. Looks like there's a few new folks on the call, or at least one or two. Does anybody want to introduce themselves and say hello? Let us know what you're here for and what you're interested in SIG Windows.
I'll go ahead and go. My name's Eric Smith. I basically joined Muzz, asked me to join today's meeting so that we can understand a little bit better, I guess, some issues that are being run into, and see if we can clarify some things or go back and figure some things out for you.
Awesome, thanks for joining. Do
Thanks.
you have Alvarez on the call? Yeah, cool, so we can discuss that with him. Cool, anybody else? Cool. So just a quick reminder, next week is Code Freeze, so next Thursday. So if there's any features that you're trying to get in, make sure you get those in. Let us know if there's anything we're watching. I know Avron's got one, the host process is in, and it sounds like we might be a little bit delayed on the node log collector. But if there's anything else, please make sure you drop it into SIG Windows chat so that we can get it reviewed and watching it. Does anybody know of anything out there that we need to be tracking?
I have a pull request which hasn't merged since a while. It's a bug fix when it comes to subatomic file mappings and so on and so forth, which is this one. It's fixed for container D for the most part. There are some issues when it comes to how the symlinks are being created, and this is basically changing or fixing that problem. Basically on Windows, if you create a symlink by default, it's just going to be a regular symlink, while for this particular scenario, it should have been directory symlink, which is a bit different. So basically, it just changes the order of the operations. So the folder is created before creating the symlink. If anyone else had some experience with symlinks, a review would be greatly appreciated.
Great, thanks for calling that out. I'll take a look at it this week. Anybody else can too. Please do. Any other PRs that we should be watching or tracking? Okay, cool. So I'm not sure if Perry's on the call. I worked with Perry last week, and we got host process up and running for in CapV, and we're also able to schedule a pod that was similar to a CNI, and so we're still making some progress there. Just wanted to let people know that the PR that had host process work in HCS shim has merged, so now we should be able to build from the HCS container D shim from the main branch. So no longer need to be building off that PR. There is one thing. There's one item that we identified with volume mounts for the host process containers. Those aren't being mapped through properly, and so we are working to get that updated so that they show up inside the containers folder that is created on the host. So that's one item that's still open, but wanted to just let folks know that it's up there. And using the containerd PR that Perry has open, we were able to schedule pods without the network setup, which is needed for the CNIs. So making some progress there. Any questions on that? Okay, great. Ravi, do you want to? This is something that's come up quite a bit on how do we actually identify nodes or Windows pods. So I'm going to open this up, but you can maybe talk to it a little bit.
Sure. Yeah. So at a high level, what we are doing in 1.2 time frame is the SIG community has come up with a replacement for PSP. It is called pod security admission instead of pod security policies. The main concern there is how do we identify Windows pods? Like, do we have a generic way to identify Windows pods during the API server admission time? Is the question that they would like to get answered, and at the same time, we as a community would like to, the Windows community would like to get answers for. So what are the existing ways to identify Windows pods? Like there are
Ravi, sorry to interrupt you. So when you say, just trying to understand a little bit more use case. So when you say pod needs to be identified and the security need to be applied, can you explain a little bit like what kind of security, what are we talking about? Why is it so important to have pod identified as Windows?
Yeah, so the security constraints that we apply to a pod, they could be, some of them could be like Linux specific, like SELinux or SecComp or AppArmor. Those are the type of security constraints that can be applied to a pod. And previously, what we used to do is we used to apply to all the pods non-judiciously, like we do not know if it's a Windows pod or a Linux pod. We'll go ahead and apply. This application of the security constraints, they happen at the admission server level, which is at the API server level, not even on the kubelet. So as a workaround, what we have been doing is once the pod lands onto a node, within the kubelet code, we strip off the unnecessary security constraints that are Linux specific. Does that answer your question, Mas?
Yes, but so when it lands and you strip it out, at that point you could tell. So when the pod lands, you could tell there's a Windows node, right? Because you could identify it. But you want to do it before that. So you are able to do it after, but you just want to catch it earlier. Is that correct?
That is correct. Because there is no reason to apply some security constraints to a pod, because like at that point of time, we do not know if it's a Windows pod or a Linux pod during the API server admission time. And that was the reason we have been applying non-judiciously all the security constraints that are, some of them could be Linux specific. Okay.
And when we apply this earlier and then strip it off, the concern is the time it takes, or is it more like some of them are, error out, or like?
Some of them, like when we looked at it, especially in the OpenShift side of things, we have another admission controller which actually applies SELinux specific security constraints. So what is happening there is some of them, they may actually translate onto the Windows security constraints in a different way, and some of them may be needed. Like for example, run as user, which is pretty much different from how it works in case of Linux. So we would like to make sure that we can authoritatively apply those security constraints during the API server admission time, instead of after reaching the kubelet, where we are like not sure, like not 100% sure that this can be removed or not.
I see. So, okay, makes sense.
Yeah, Moz, in other words, right, we don't want the kubelet to do any sort of policy application, because that's what is happening now, right? One entity is applying some policy on some pods, and then the kubelet is coming up and then removing it, saying, oh, these are Windows. We're trying to not burden the kubelet with those sort of decision making, and letting this other entity that's trying to apply it, let it take care of it and let it be Linux versus Windows aware.
I see. So separation of concerns. Okay. Okay. No, makes
Correct.
sense. I was just trying to understand, like, in today's case, what is the pain point, like, for the, for operators like, OpenShift or Edge or any one of those.
Yeah, and it also becomes an issue. Becoming an issue, or became an issue with the new pod security policy that is coming out in 122. Currently, I believe the restricted policy wouldn't actually apply to, won't really work with Windows containers. And especially when we start to talk about a host process coming in, we need a way to be able to restrict that field for just the Windows components. So.
Yeah.
Makes sense. Sorry, Ravi, go ahead. Yeah.
Yeah, like that is the main reason that we have started this work upstream in the Kubernetes community. So like at this point of time, we are distinguishing Windows pods from Linux pods using the labels, technically the node selector in the pod and the runtime classes. There are two different ways where we can say, this is a Windows pod, I would like to get it scheduled onto a Windows node. But one of them, which is like using node selectors, it perhaps is not good enough in terms of security. The main reason is anyone can apply a label. Like say if I'm submitting a pod, even though I'm not a cluster admin, I can specify the node selector which says I would like to get landed onto a Windows node. Similarly, I can apply a toleration which says I can tolerate a Windows node. Let me get scheduled onto a Windows node. So what the auth team has suggested is go with the runtime classes. The main advantage of using runtime class is it has to be created by a cluster admin, and it has to be given to the end user, like saying, hey, if you want to use Windows, this is the runtime class that you have to use. So using those runtime classes, which cannot be created by the end user, it becomes easier and more secure for developers who are submitting their pod requests to the cluster. So what I have proposed in this KEP is rallying behind those runtime classes. Like, can we use the existing runtime classes at the API server admission time and say that, hey, this is a Windows pod. I would not like to have the labels plus toleration, just labels and toleration without nodes, without runtime class associated with it. So this falls in line with what the SIG auth team is doing using the runtime classes. And the other option that I've mentioned is having a field in the pod spec, which says the operating system is Windows. But as I mentioned in the alternatives considered, the main problem that I see with it is we have two different ways of specifying the same thing. There are other entities in the cluster which are actually using runtime classes to do something similar. Why can't we piggyback on that? So that's all I have at a high level, or like if anyone has questions or any clarifications, please.
Yeah, awesome. Thank you for taking this and turning it into a KEP. Anybody that has any thoughts or feedback, please make sure you review the KEP and read through it. I know it's on my list to take a look at this week. So, and we're targeting this for 123. Is that right?
Yep. Yeah. This is for 123. So the pod security replacement, the pod security policy replacement, it merged yesterday, which is in alpha stage. So in 123, they're going to go beta. So by that time, we need to have like at least a direction which says, this is how we are going to identify Windows pods. Like if we go with the runtime classes, perhaps we can say that because the SIG auth folks, they have mentioned that identifying Windows pods is a problem for them. And if they have an identifier, it would be easier for them to do it in their implementation. So we can actually piggyback on their admission controller too.
Great, thank you. Yeah, Muzz, I had the same thing, and I know it's come up several times in the past year or so on various PRs on how do we actually identify Windows pod, and so that was one of the things I was kind of suggested, and I need to read through and figure this out, think about it a little bit harder. But yeah, thanks a lot, Ravi. This is great.
No problem.
Okay, so next one is projected volumes and container user. Avrant, you had figured this out. You had identified this bug, and we've been kind of going back and forth. And I talked with Muzz, and we brought Eric along. So maybe quickly do a quick recap of where we're at, and then Eric can help answer some questions.
Yeah, sure. So the way we hit this problem was, it was like what Ravi was talking about, OpenShift having these admission controllers that apply a bunch of security context onto pods, and they do it whether it's a Linux pod or a Windows pod, it's not aware, right? So one of the security context fields that was being applied was run as user. And in the latest release, there is also a feature that results in a projected volume being attached to every pod. And this projected volume, has a bunch of secrets, some certs that can then be accessed within the container. However, for Windows pods, if I bring up a Windows pod and this happens, the run as user capability is set, even though this is very Linux specific. And what happens is there was a KEP introduced that said, for projected volumes, I want the correct permissions set within the container for the files that are being projected or the resources that are being projected. And so what that feature does is it tries to go and say, okay, for this user, I'm going to do a bunch of chmod commands and a bunch of chown commands, or just a single one. Except, of course, if you do this for a Windows pod where the run as user is set and you try to do chown is not implemented for Windows in the Golang library. That causes, the end result is the pod doesn't come up. And so I started looking into it. And then what I realized is for one, we need to make the pod come up, of course. But then I was unclear whether the correct ownership is being applied similarly to the way it's being done on Linux. And that's what I've been trying to figure out and try and do. And I've discovered a bunch of things, like, for example, unlike Linux, with Windows, the users have to be created when the container image is itself being created. So you can't attach like a random user to a particular container image. They need to have been created as part of the container image creation. And there are some interesting things like, container user. If I go inside the container, like exec into the container and try to query container user, I don't see it listed when I do get local users. So long story short, what I think we are trying to achieve here is to ensure that the correct permissions are being applied with respect to projected volumes being used with Windows pods.
Okay, yeah, thank you for that description. Muzz had shared me a little bit of context, and that aligns with what my understanding was. Let me paraphrase it real quick, just so you can confirm that I understood. But I think this is what you're looking for. I think what you're looking for is a way, based on a set of users that will exist inside of a container, to be able to go apply some, in Windows world, ACL settings, but security descriptors on the files or resources for that projected entity, so that you can control which of those users has access to which file, etc. Is that basically right?
That is correct. And in fact, I have a PR open where I'm actually trying to do this, and that's where I started to run into trouble, because in the Linux world, right, you could do chown on a particular user and it'll get applied within the container. Whereas in Windows, if you try to get the SID off that, say, container user, the host is unaware of that user, right? It's all inside the container context.
Exactly.
Yeah.
Exactly. Which is where I think the challenge is going to be. And you want to do all this obviously when the container is not running, right?
So I'm trying to think. Somebody can jump in here. I think that not completely sure if the container goes to fully running at this point. But I know that the mount points have been created. Somebody can correct me about at which point does the container go to fully running. I don't think it is definitely not gone to fully running, right? It's in that container creation process where it's trying to mount these volumes and ensure everything is done correctly. So it's at that point, I think.
I see.
Mounting would fail. It won't reach the running stage. The pod won't reach the running
Correct.
stage.
Yeah.
Mount is the stage where it would fail.
Okay. So if there's, it sounds like you mentioned you have a PR, but it sounds like the gap right now is getting the list of SIDs for the container users so that you can apply them on that outside resource.
That is true. I'm going to link to the PR here so that you can look at it. Maybe I'm doing it completely wrong, and you can tell me and I'll, fix it.
Well, no, I actually, what you're saying, I'm sitting there wondering, yeah, crap, that would be an issue. So, I'm going to have to go talk to some folks on our end. But
so
go ahead.
I've done some tests where we specify the run as username as container administrator, and I can, if I mount in the host volume, the host directory, like the C root, I can modify and mess with all the different files. So I can change my SSH key and all sorts of things. If I run as a container user, I'm not able, I can see those files, but the ACLs are blocking me from being able to edit them. I think I can't even cat them. And so my question that I put on the thread there was, if we had user one in container one and user two in container two, and these projected volumes get mounted in, and then we map in the host volume into container one and container two, can container two now go to where that volume is entered and see that file? My guess is that it can't, but I think
I'd have to hear that setup one more time, but let me just say one thing real quickly. You mentioned, we'll get past this and then you can describe that again. But you mentioned that as container administrator, you could kind of have access to whatever that was mapped, but as container user, you couldn't. In both cases, that those container accounts kind of only exist in the container, they don't exist on the host. But what is true of the container administrator account, he's a member of the administrator group, which is essentially that administrator group's just a well-known SID itself. So he still is an administrator effectively from the perspective of the host. So if he can see some host resource, he could manipulate it, which is why I think when you map the volume, the container administrator had access. Whereas container user, he wasn't part of that administrator group. And the host is like, I don't know who you are. So any ACL check is going to fit. He might look like everyone. He might be a member of the everyone group. So he might have read access to some things. But I think that's the difference you're seeing there. But can you explain that setup again, where you were?
Yeah. So essentially,
hey James, can I give it a shot? Because I know you had asked me to try and do this, and I wanted, as soon as I get off the call, I want to go and try it. So can I give it a shot to explain this, and you can tell me if I'm wrong?
Go for it.
So I think what James is asking us to do is bring up a pod. It has two containers. On both the containers, you attach projected volumes.
Is it the same projected volume?
Different projected volumes. Projected volumes. And then also attach like C:// as not as a projected volume, but as a mounted volume to each of these containers. Then go to container one, which belongs to user one, and try to access the projected volume for user two and see if user one has access to user two's projected volumes. Is that correct, James?
Yes.
Okay, but you said they're different projected volumes.
Correct.
Okay, in that case, I agree with James. I mean, it's worth testing, but I agree. I think he said he did not believe they would have access. Unless my understanding of what these projected volumes is wrong. I should warn you guys that you know, I kind of work more at the kernel level, so some of these higher level concepts, you know, Kubernetes names for things and stuff, I'm not super familiar with, so I may be.
Yeah, I can give you. Yeah, the TLDR version of a projected volume is there was always this requirement, or people were asking, hey, I want to map multiple things onto the same like directory inside a container, and I don't want stuff to be overwritten. So what the projected volumes does is it says, oh, for these list of resources, there are only certain resources like secrets, downward APIs, and I forget the secret, downward APIs, config maps, and service account tokens. You can collect all of that and project it onto a container that's running, and it'll show up. You can project it to /projected file / secret or downward API, and it'll all be in that same directory.
I see. Okay, that's a little bit different than I thought. Okay, thank you for clarifying that. In that case, I take back what I said. I'm no longer confident that they would not see it. So basically, let me paraphrase this. So there's a set of resources that would get projected into each of those containers, but are they backed by the same common set of resources?
They could be, but they needn't be.
Okay, so they might not be, but I think the question would be if they were. I'm assuming that's the question. If they were coming from the same backing resources or backing files, and they're projected into both, is there a way to limit, container, user one from seeing it from one container, but not user two from the separate container? Was
Correct.
that the right? Okay.
Yeah.
Okay. Yeah, and I don't know enough about how that projection works to speculate on what the result would be. Muzz, do you know, are those just bind filtered on our end? Bind filt mapped for the projected stuff? I'll have to go look into it on our end and understand how that works. So.
Okay. Well, thank you for helping. I think at least the container administrator SIG helps make sense on why we can see that. So I think Arun can report back, and we'll continue to research it as we go.
Yeah, I'll give you that. I'll try this out today and tell you what happens, James, on the same thread.
So.
Okay, thanks, guys. I'll see what I can find on my end and report back to you.
Cool. And with that, I think we're at time. So unless anybody else has something pressing, we'll make sure you get it onto the agenda for next week.
Thank you.
Okay. See you, everyone.
Okay. Thanks, everybody. Nice to meet you.
Bye, folks.
Bye.
And we have SIG Windows after hours coming up here. I think I'm going to be running it today. So if you're still hanging out, we can go from there.